my focus today, I think I probably hit it about right, is going to be on what do we know about climate impacts, both climate variability, but also climate change on particularly fisheries. I'm going to talk specifically about marine fisheries today, although I'd be delighted in questions to talk about protected species like whales and other kinds of neat things like that. Much of what I'm going to say really applies in principle to what we are observing and think is going to happen to protected species, marine protected species like whales and sea turtles and that kind of thing. I'm delighted to have Rick here as well to follow up, the actual practitioner of fishery management for a suite of species in the mid-Atlantic, and he'll describe some of the recent really fantastic steps that are taking place as the dialogue in this country and around the world really is being transformed as we speak. So I'm going to be talking about this question. I'm not going to answer it, but I wanted to throw it out there and say, you know, the big question is what would climate-smart ocean management be? What would climate-ready fishery management look like? How do we get there? How far away are we now from it? And what would it take? Where am I pointing? There we go. And just a quick reminder, I will be mostly US-centric in my examples. I understand that part of the incentive here is to give you some fodder for stories and questions and ideas, so I'll draw largely from US examples, but I'm going to go global as well at several places. So just a quick reminder of what we're looking at, because usually the general public and the rest of us, when we see maps, we don't usually see the ocean, see it from the ocean perspective, but you know, you can see the land, and obviously you can see the ocean. What's in the blue circles, sorry, the light blue, are the U.S. exclusive economic zone. That is the place out to 200 miles from our shore that the U.S. claims responsibility and privilege for managing the marine resources under that area. So just context, geography, the federal government manages the marine sources in general from about 3 miles off the shore out to 200. The states manage the fisheries and marine resources and stuff within the 3 miles. And so obviously marine resource management in this country is very much a collaboration, but with some unique responsibilities and roles between state governments, federal government, and tribes. You can see that if you squint and put together all this light blue area, there's more ocean area that the U.S. is responsible for managing than there actually is land area, at least in the continental United States. And the big orange circles here are what are referred to as large marine ecosystems. These are the kind of big oceanographic systems that function in one way or another as a system together. And one of the core messages here is, well, two messages. One, the who's responsible for dealing with these resources, and particularly dealing with them in a changing climate, which is the challenge. And two, that the regional ecosystems, of course, are defined by their physical and biological characteristics, which, as I'm going to describe, and you already know, are in fact changing and projected to change dramatically in a changing climate. Microphone, thank you. I'll do that. I'll try not to wander too much. So this map, part of my implication here is this map may look a little bit different, say 10, 20, 50, 75 years out, because the nature of these ecosystems, their physical, chemical, and biological characteristics, is probably going to change quite a bit. So why should we care about marine resources in a changing climate? Things change all the time. What's the big deal? Well, there's a lot at risk here. There are a lot of resources. Across the planet, it's probably more like 2 billion people now depend on marine resources worldwide, most of that for primary food and jobs, particularly in tropical areas in developing countries. In the United States, just fisheries alone, about 1.3 million jobs, combined commercial, seafood industry, recreation, and tourism, probably a contribution upward of $200 billion in sales and income within the United States. Probably a lot more than that if you actually take in more of the tourism and recreation dollars. That all feeds pretty significant parts of our nation's economy. That is these coastal economies. The coastal economies are the engines that drive much of the national economy. 58% of US GDP, a lot of people, as you've heard, 50% or more of the population. And coastal infrastructure is, as you've probably heard, at risk in a changing climate from a variety of things. There's a lot of other risks, and I know you've talked about some of that, mentioning Vibrio and other kinds of diseases. In a changing climate, there are implications for public health issues, diseases, harmful algal blooms, And as I'll talk about, why should we care? Well, there's some stability and security issues, particularly if you think about that first statistic, the 1.5 billion people across the planet, many of them that depend on coastal fisheries for their primary food source or their only job. If those fish stocks start changing and they can no longer access, say, half of the protein they need, or those jobs start disappearing, particularly in tropical areas again, that could perhaps result in a lot of people without food and jobs, which often results in unrest, and that would be the link to perhaps some security issues internationally and affecting U.S. interests. So what's at risk? There's a lot at risk, and that's partly why we should be thinking about and planning for climate impacts on fisheries and other marine resources. We know that climate change is already impacting ocean ecosystems and services, and the projections are that these impacts are going to significantly increase. So this is a cartoon that I used to just play out. What do we think those impacts of climate and a changing climate are going to be in ocean systems? And of course, at each of these steps, there are a lot of questions about what will actually happen, what are the connections, but I'll just play it out. So with climate change, that is increasing temperature, or beginning with increasing CO2 levels, the global warming effect, increasing temperature, changes in precipitation, increasing atmospheric CO2, as you've just heard, oceans absorbing a lot of both that heat and the CO2, that's driving significant changes in the physical and the chemical conditions of the oceans, both out in the blue water areas, but also coastal areas, particularly increases in ocean temperature that drive stratification and circulation, the loss of sea ice. I don't know if you all talked about that, but a real clear evident sign of one of the major changes. Changes in freshwater input, of course, affecting most of the coastal areas, rising sea levels, and increasing ocean acidification. So you hit many of those in the previous sessions. So those are the things that drive where and how many critters there are out in the ocean, right, as you've been talking. So with those kinds of changes, a lot of potential biological impacts, changes in productivity, which has been documented in a number of places, changes in the phenology, that is the timing of migration and reproduction, changes in the distribution of species, which I'm going to talk about, changes in the abundance, which is projected for many species, and changes in the composition of the communities. We're used to managing a suite of fisheries, for example, that we manage together, but as things change, as some of them move north quickly, some of them move north more slowly, what we expect to happen is a whole mixing of those communities. And as I said, some potential disease impacts and invasives you all touched on earlier too. So these would have very significant social and economic implications. It would obviously affect those that are trying to catch those things. If they're moving northward or deeper, the fishermen may not be able to get them. They may be catching other things that maybe they're not supposed to catch. There are a variety of implications for the economics of fishing and recreation and tourism. And as I said, the last bar there moving across to the right, a number of international implications, particularly at places where these resources are crossing borders, where we have international agreements with Canada, for example, or Mexico, for example, and how much each one gets of a certain stock of species. And so to round it out, what does climate-ready fishery management mean or marine resource management mean? Well, there are places here where we can actually make decisions and potentially prepare and do something that might help reduce these impacts and increase the resilience of either the fish stocks or the fisheries. But those are relatively few. They're on the biological and social side. Obviously, the mitigation effort is perhaps most important to try and stem the tide of the change, and that really functions both at the climate and physical levels. So some key questions, how will, and I'm going to focus primarily on warming, changing ocean temperatures, which have been well documented now in pretty much globally. I'm going to use that as my indicator, my example of climate-driven change in the ocean. So posing these kinds of questions, how will warming seas affect ocean productivity? Obviously, the productivity determines eventually how many fish will be out there that can be caught. How many boats, how many jobs, how much revenue can be generated? How will the warming affect what's out there, how many of them, but also where they are? You know, fishermen are very coastal based. Fishermen go out from a port. They have homes. They go out with boats to a certain place to catch a certain series fish stock or a series of fishes. As they move, there are huge implications for where those people live, where the ports are, where are the processing plants, are the chains in that seafood industry still going to connect? What will need to happen on the shore side to support changes on where that fleet is or where it needs to go based on changes in abundance and distribution? I got a little ahead of myself. Will the fish stocks follow the changing ocean temperatures? Will the fishermen follow the changing fish distributions? And then I jumped ahead. Will the communities and economies adapt? How will all those pieces still fit together? And then the question I come back to is, how would you sustain, how would we sustainably manage fisheries in this changing time? So I'm going to give a few examples from the Northeast. I'm not sure where you all are from, but I thought at least we'd have a healthy contingent from the Northeast. And the Northeast U.S. is actually one of the places that has very well documented trajectories of both climate-driven changes in ocean temperature, but also biological responses. The fish stocks are changing with shifting ocean temperatures. So this is a series of graphics. The upper left showing, reminding you what the northeastern United States ocean system looks like from a satellite, probably in about the spring or summer. The orange is the, I have a pointer, don't I? So the little arrow there says Cape Cod. So Cape Cod's somewhere in there. If you're not used to looking at ocean instead of land, the orange here is all the land. I think that's the Chesapeake, isn't it? Mm-hmm. Yeah. Okay. So we're sitting somewhere here, Cape Cod, and so you can see the colors here. This is the Gulf Stream sweeping up. I think the warm colors is probably temperature, and so you've got warm Gulf waters sweeping up from the tropical latitudes, sweeping across. You've got colder water, as you can see, sweeping down and around from the northern areas. You've got this beautiful mixing in the middle, and that's a real typical system. That's what the Northeast looks like, at least during the spring, summertime. And one of the things that people have been tracking, of course, the basic is the temperature of the upper layers of the ocean. And this plot here is showing that temperature of the sea surface temperature has been changing in a variety of ways. And this is my time to remind us all, of course, that change is the normal pattern, right? Variability. We have seasonal changes from cold in the winter to warmer in the summer, but then we also have these other kinds of cycles. You can see there's a kind of a cycle here that seems to be at about a 10-year pattern, and that is in fact what you see. There's a 10-year cycle on the North Atlantic called the North Atlantic Oscillation that is part of the pulse of the ocean system on the North Atlantic. So trying to understand climate change in our oceans or anywhere, as you know, is about understanding what is that normal pattern of variability that we would expect. And then the question, is that cycle changing? Is it pulsing upward? Is it changing this? Is it the same? Is the duration of each of those pulses the same? Is the 10-year pattern switching down to a 5-year pattern? Those are the questions about climate change in ocean systems, but in the land systems as well.
What was that 10-year cycle called again?
North Atlantic Oscillation.
Okay. And do we know what causes that?
I'm going to
I'm going to come back on that.
Got 2 minutes left.
Gotcha, 2 minutes. Okay, so we're quickly going to go. So temperature's been changing in most ocean areas, particularly in the Northeast. The Northeast is one of the 8 top hotspots for climate-driven changes in the ocean. It's one of the places that is changing the fastest from ocean temperature, and the fish are following. Over the past 40 years, the analysis shows that it's been generally upward trend. In fact, 2012 set all kinds of record temperatures for in any time ever since we've been observing temperatures, warmest temperatures in the Gulf of Maine, North Atlantic area. And this has been an upward trend over the past 40 years, and the fish stocks have been following them. The graphic is showing you, the graphic up here showing you where the distribution of red hake, one of the species commercially fished, in the period from about in the 70s. You can see the red are the hot spots of where the major distribution of that stock, the red hake fish were. look what's happened by the late 90s and early 2000s. Basically, we've lost that southern part of the population. They seem to be shifting northward, or at least the northward population is what's left. This is the general pattern we're seeing. In fact, 2/3 of the major commercial stocks, fish stocks that have been studied, are showing the same kind of pattern. A couple important caveats: they're not all moving at the same rate, so that's where we start getting this mixture of species that we thought used to be these biological communities functioning together. Well, what's starting to happen is we're starting to get those to pull apart, and there's significant implications to that. So there's some really neat work that's just come out last year continuing to analyze that, and this little graphic shows that on the average, the red arrow, these stocks along the East Coast are moving northward about 12 miles per decade. But the important part are all those other lines, which is the individuals. Some of them are sprinters. Some of them are still sitting there moving very slowly. And in fact, that paper started looking at similar patterns, and what you see is there, in many of the regions across the country, you're seeing similar trends. That is poleward or northward migration of the major fish stocks and other species that track the pace of change in the ocean temperature. We see, and it's one of the questions was, will fish stocks track the change in the warming at ocean temperature? The answer is they track it really closely. And in fact, there are a couple areas, that are pointing downward. Like, look at the West Coast. It's not poleward, it's going the other way, because this was I can't explain it right now, but they're still tracking temperature change, but the temperature change was a cooling period. The Gulf of Mexico is a really interesting place. Can they move north? No, they can't. They're moving westward. Really interesting story there. Okay, so the other question is, this is red hake again, and the years across the bottom, latitude across the top. What this is saying is red hake are moving northward, the distribution. So one of the questions is, were the fishermen able to follow this trend of the fish moving northward? Remember, they're coming out of ports in New Jersey and other places. Can they? And the red line is the landings, reflecting the fishing effort. And you can see that they tracked it well until about the middle of that, and then they leveled off while the hake kept going kind of northward. And I'm really simplifying this a lot. That was kind of the trajectory. And this is why couldn't they keep following them? Well, because there were management restrictions. For good reason. The fishermen there couldn't, with certain net sizes and certain capabilities, were not allowed to go into those northern waters because of some good reasons, that they didn't want to affect other things, or other folks had the right to go do that. So I'm trying to bring in the fact that our ability to respond to these changes is going to very much involve the management side of the house, which is going to have some characteristics of flexibility and responsiveness, so that both the fisheries can track the fish stocks, but that we're also keeping a good eye on what's happening to the stocks themselves. And I'll come back to this. So one of the questions is, well, is this all bad news? Everything's moving north. There's some good news here. Some species are going to love the future. These little guys in the red bucket are called Atlantic croaker. And they're more southern stocks, southern species. They're going to love the future. They're sweeping up from the south into the New England area, rich waters, and they really are. They're some of the sprinters. And some modeling efforts that our folks have done have said, well, if this continued, how quickly would they move forward, and how quickly might they become a big enough population so we could have a fishery on them? And so that's what some of the really neat work is. It says that croaker are going to love the future. They may be a fishery of the future. And that's where the additional work is needed. So a lot of what I've been talking about is this term of climate velocity. Climate velocity just refers to how quickly the velocity at which both the temperature is changing or the velocity at which the species are following it. And you can see that I put this here just to the orange areas are the places where there's very rapid change in both temperature, and those are the places where we'd expect species to follow. And a little nugget, who do you think? So organisms, critters are able to move. Organisms on land going to move and track their changing temperature preferences faster, or is it going to be faster in the marine area, or is it going to be the same? What do you think?
Marine
Marine, 7 times faster in the marine environment. A really neat paper, did that big analysis. It was, some people didn't expect that. Partly because they said, well, there aren't as many barriers, maybe they are able to disperse faster. But what that says to me from a management perspective is that the marine resource managers have got to be really on top of it. We need to have our finger on the pulse of the system because things are going to change potentially very quickly, and we need to be able to change the management side as well. So this is another interesting study looking globally of what's the projected change in fish catch based on their thermal preferences, and then kind of overlaying that on global projections of global changes in ocean temperature. And if you play that out, you got to assume that fish will go where they stick with the temperature they like, and then you play that out over the next 100 years or so. The red areas are places you can see from the key where you expect to find maybe up to 30 or 40% decline in the fish there, i.e. in the fish catch. So look at those red areas. I circled some of them, okay? In the blue areas, up at the top, high latitude, look up near the Arctic up there, you expect perhaps 50% increases in the catch. So why is this? Well, it's because if fish stay with what their temperature preference is going to be, the fish in the south and the tropics are going to move north, and there isn't a whole lot that's going to move back in there. So the equatorial areas where those 1 billion people live depend on fisheries for their primary food source, and they're potentially in big trouble because those fish catches could go down 50%. Again, this is just an estimate projection. Norway, Russia, Iceland is going to love the future because with the warming oceans, those high latitude oceans become much more productive. That's where all the cod and other big fisheries are going to be. And they've just recently validated that in fact is the pattern that is being observed. This is a cartoon version of a paper that came out last year. Pew put this cartoon together, but if you look at the nets, the colored fish in the nets, and you start over on the left side, where am I? Oops. You can see that the colors, blue fish are cold water fish, red fish are tropical fish, and what you see as you move from left to right is generally a loss of the blue water fish. And you end up with basically orange and red fish. That is, it's called a tropicalization of the world's fish catches. And so there's two slides. The pattern on the left side is really for subtropical and temperate zones. So New England, for example, the Gulf of Maine, Mid-Atlantic, that's kind of that what we expect to see here. And what the pattern is that in the 70s, we had this nice mixture of cold water fish like cod, orange or red fish like croaker. But what's happened over the past 40 years is the distributions have shifted, the abundance perhaps has changed, and so we've lost many of those a decline in the cold water fish, more of the warm water fish, and the projection is that would continue, and there are implications both on how much and who would catch and how you'd catch them. And the tropical area is the one on the right. That's the, again, real concern for that billion people that depends on them. There's nothing replacing those fish. You see, if you go all the way to the right, what's in that net? Not so much. Again, these are projections based on what we think is going to happen to ocean temperature and assuming that the fish will follow where they prefer to be. So one of the big questions is, well, what are the characteristics of climate-ready marine resource management? And these are some of the 5 or 6 things that people have said. You got to sustain the basics of any conservation of natural resources. You got to make sure it's got its habitat there. You've got to make sure you've got robust populations. You got to have populations that have the right size distribution. More big females is better because they lay a lot of eggs and make a lot of babies. That's better than a lot of small females. So sustain the basics, plan for the future. Much of our natural resource management, not just fisheries, is based on actually managing based on past pattern. We've got to change that and manage based on a future that's not like the past. Monitor for surprises. This is one that we're actually not doing so well. And have flexible, responsive management structures. Consider barriers to adaptation. And the last one I'd say is, people have said, is manage for resilience. What would it mean to manage fish stocks for resilience, that is, to try and sustain them for 25 to 50 years rather than perhaps 10 to 15? It may mean different management decisions. So this is a cartoon that plays out that nice fish there. His first circle is where he was. The dashed line is where he may go based on changes in sea temperature. You can see he shifts up in latitude, poleward. It could be a variety of things. That's his climate-shifted distribution. Once he gets up there, he bumps into this other thing, and there's interaction. Remember, these are mixing up where species are. And the other implication for management is we had a wonderful protected area that protected its nursery grounds down below, but it's now moved out of that. And so we've got to rethink about where we maybe need some new protected areas. Again, manage for the basics. And the other thing is it crossed a geographic or governance line. It went from management under one fishery management council, now it's managed under a different one, or United States, Canada. So lots of implications. I'm not going to run through this. I put a few resources here. These would be the places I'd go if you wanted to see some more on, particularly fisheries, protected species, and oceans. Some really cool stuff. And we've just put up, so I'm not trying to plug NIMS and National Marine Fisheries Service or anything, but we just created a new website. It's the second one that provides a whole series of stories. We've been pulling together stories on research on climate impacts on fisheries and protected species. So there's a great set of stories under that second bullet, climate, fisheries, and protected species. And I thank you.